To begin this Hardy Weinberg experiment, you're going to need a couple of materials. You're going to need two different colors of poker chips. In this case, we're using blue and red. And you're going to need a handout provided to you by your teacher. Make sure you have it back in front or you have two sheets. In this simulation, the blue chip will represent a dominant allele and the red will represent a recessive. Everyone will begin as a heterozygote with one of each. On your handout, you will need to record the initial class frequencies with everyone being a heterozygote. So basically just put in the number of students in your class. And your initial genotype will be a heterozygous with a capital A, little a. You will need to find a random partner and you'll exchange alleles to create an offspring. You will do this twice, one for each of you. In this particular scenario, the offspring is a heterozygous, so they will maintain both of their chips. In this second simulation, both offspring turned out to be homozygous dominant, so both participants will need to exchange their red chips for blue ones so that they are both homozygous. At this point, you will need to find a new random partner and repeat the process until you have completed a total of 5 generations. After completing your 5 generations, you're going to record the final class frequencies. In this case, we had 2 homozygous dominant, 1 heterozygous, and 1 homozygous recessive. Flipping to the other side of the page, you may want to write down your results as a quick reference. Beginning the math with your dominant alleles, you're going to want to record how many students in your classroom ended up being homozygous dominant and multiply that by 2. Then you're going to record how many were heterozygous and multiply that by 1. That'll give you a total of 5 alleles in this particular scenario. To find your p-value, you will need to record your total number of dominant alleles over your total number of alleles. In this particular scenario, that would be 5 over 8, and you're going to want to put that in decimal form, which will be 0.625. Now you will repeat the same process for your recessive alleles to find your Q value. To check your answer, add up your 2 decimals and ensure that they equal to 1. This concludes your case 1, and you may now move on to case 2. In case 2, you will again begin as a heterozygote, and you will trade for 5 generations. However, in this case, if you turn out to be a homozygous recessive, you will sit down as your offspring will have died. This will represent a defective recessive phenotype. Be sure to record your results and move on to case 3. In case 3, you will again begin as a heterozygote, and similarly to case 2, if you become a homozygous recessive individual, you will need to sit down because your offspring will have died. However, if you turn out to be homozygous dominant, you will have a 50-50% chance of survival. You will need to flip your poker chip to determine if you will live or die. One side will represent life and the other will represent death. This simulation will represent a heterozygote advantage. Be sure to record your findings.